So I'm talking about behavior. So let's see, where is the right button? So why should we consider behavioral when we have models? Models don't behave. So if we are having models of behavior, they are still equations, and models are free of behavioral effects. But the thing is that as soon as we start using models in real practice, behavioral elements are brought into by ourselves, by the users. So the theme of my presentation goes along this line, so that what is the human impact of model-based decision analysis and model-based systems analysis? I'm going to go through this theme along Howard Reifa's career, so to speak, and much of what I'm saying is related to decision making, but actually, finally, I'm trying to convince you that it relates to systems analysis in general quite clearly as well. So this is not a coordinated thing that everybody starts with the same book, but I do start with this book. And one could say that some of the reasons why this book came about was that Reifa realized that the statistical decision-making based on statistical analysis is not enough, so he brought in new concepts, the structural concept of decision trees, and then subjective probabilities, which sort of brought in the behavioral world into the picture. And that's how it started. In his personal account, where he described how decision analysis came into his focus, he describes that the behavioral effects were already sort of in the surface in the 60s, but then they were sort of discussing how to obtain reliable estimates of judgments from the experts and how to improve the elicitation methods. So the behavioral aspect was seen important by him, but it turned into more practical things later on in the area. The famous book by Keeney and Reifa is a lot about theory, models, but they also, I quote, say that these psychological insights will undoubtedly help analysts design better assessment protocols in the future. And they suggest that ask elicitation questions in multiple ways, check consistency, and discuss the results. So there was a feeling that we need to improve the way we use the models. So how do people make decisions? The behavior of the decision making is very, very strange. So the main observation is that the axioms of rationality that we do in economics are not followed in practice. And that descriptive psychological research has shown what kind of things take place in judgment and decision making. Of course, you could say that the value function in itself is a model of behavior, what we use in multi-attribute theory. But then things that come into the picture include all kinds of cognitive biases, motivational biases, anchoring effects, scope insensitivity, and so on. People use very strongly heuristics in their decision making. And the way they approach decision problems could be using fast and slow thinking, system 1, system 2 thinking. So how do the models take into account these, or how can we incorporate this kind of behavior into the decision analysis is a challenge. So human behavior drives the decision analysis process. So decision analysis is to support decision making. It supports human behavior, but actually human behavior very strongly drives the process. So once we start the supporting, we engage in a social interaction situation, we have dialogue, we communicate, and these things come into the whole problem-solving process. Behavioral effects take place in problem structuring, framing, choice of criteria, and how do we approach uncertainty. And there's a lot of literature on how biases influence the elicitation procedure, subjective values, and so on. So the textbooks have recognized this for many years. We have excellent textbooks by famous authors, some of them are here. And just this year, somehow Detloff and Gilberto Montebello decided that we still need one summarizing paper. So they went through 175 papers and observed that, or identified 30 biases and provided ideas how to deal with them. And this somehow reflects the fact that even if we know these phenomena, we have challenges to deal with these phenomena. So let's have a look at some of them. So this is a list which they provide. So typical phenomena include, for example, anchoring, gain-loss bias. We see the losses differently than we see gains. And other things include the range in sensitivity. And one of the phenomena, which is the so-called splitting bias, is a very tricky one, which I'm going to go through a little bit more detail. So the splitting bias refers to the situation that, imagine that we are evaluating, we're having an environmental decision problem. We have a value tree type setting, we have economic factors, environmental factors, we have two environmental factors. One is recreation and one is something related to nature in itself. So initially we would be approaching this problem with three attributes. And let's assume that the alternatives are such that the range of weights would be seen as important in all of these three dimensions. But then somebody says that, okay, since it is an environmental problem, shouldn't we have a more detailed description of the environmental factors? Okay, then we decide to split these elements into more fine-tuned attributes. So we will have 5 attributes related to environmental issues. And then we consider this choice of alternative with respect to these attributes. And now there are 6 attributes. And it's very natural, or very often people do it this way, that they think that whatever we see is about of equal importance. So we easily say that this is as important as any other of these. So here the weights would be 1/3, but people start to say that, okay, this seems that each of them are as important. So what would be the result of this kind of thinking is that originally the ratio of weights between environment and economics would have been 2, but in this new setting it would be 5. So such a big difference in the consequence when you start using this, and this is a phenomenon which can easily happen also in modeling in general. So you start modeling certain things that you feel important in more detail, and this could lead that the whole picture becomes distorted. So can we do something about this? Okay. So in theory, it should be that even if the number of environmental attributes increases, the ratio of these two sets of attributes should not increase. But if it happens that the more attributes you have in environmental branch, the more weight you give. So this is something that we should avoid, and then we tried to see what happens in this situation with this was a lake regulation case. We had students, it was a real case, but we had students and we played with the students, we guided them to avoid the splitting bias. So they were doing all kinds of hierarchies, value trees, and they were indeed able to provide weights consistently. But the stakeholders, we gave them guidance, we described the phenomenon and said that let's do this. And what they do show is consistently a systematic bias. So this is a tricky thing which exists, and we have to be aware of this. So perhaps do more hierarchical weighting, which sort of eliminates the possibility that the multiplicative element goes through the whole thing. So what we really need still to to discover new ways to avoid these biases. We have guidance, different ways of guiding. Then we can, of course, try to think that would it be possible to de-bias by sort of letting people do the analysis in one way, and then we would somehow calibrate their responses and fix the biases. Or we could think of having procedures which sort of have biases cancel out each other. But this is still an open field. Now, taking the next step in Howard's line is he published the book Smart Choices with Hammond and Keeney, and this book was supposed to be a sort of a practical guide to laymen, or almost, so that the gap between how people actually make decisions and how people should make decisions should be sort of narrowed by people doing something like this. So they have a PROACT framework where the structuring phase is done, but then they present a method which is called the even swaps method, which carries out the procedure. And I'm going to quickly show you what this process is all about. The idea is to make you have alternatives and you have attributes, and you want to sort of shrink the problem by eliminating things, and the way you eliminate the alternatives is by preferential dominance, and the way to create this, you change certain first you observe that certain things are practically dominated, so this is an office selection problem, but then you would do an even swap so that the one alternative becomes equivalent to another, becomes a new alternative, so to speak, but preferentially it is equivalent to the original one. And this can make the one attribute or irrelevant, and then this is the way the process goes on. So this is a very convenient process, but what can happen in the process is that you can, in theory, you can go through the process in many different ways. You can start eliminating alternatives, you can start eliminating the attributes, and in principle you should end up in the same final choice. But does this happen is the question. So we did experiments with the software that we have for this particular method, and what turns out to be the case that indeed we end up in different final solutions. And one explanation in the studies that we did was that there's a phenomenon which we call the measuring stick effect, that when you are doing the comparisons so that you always use one attribute, like pricing, as the thing against which you are looking at the other things, then that particular attribute becomes more important in your head than the others, and then its importance is emphasized. So we did an experiment where the students did the same problem using different routes or different paths, and those who used the pricing path got the cheapest apartment 80% of the time, and the other paths did not lead so often to the same alternatives. So when using money as a measuring stick in the swaps, the cost attribute tends to be overweighted. So this kind of phenomena can happen in all kinds of comparison things, and it's good to be aware of these possibilities, and we need to sort of pay attention and perhaps do alternative processes to see if this is a real risk in the process. Of course, when we start doing, and in practice when we are doing decision analysis, it's typically a group. So behavioral challenges are even higher in groups because the social process starts to have an active role. There can be strategic behavior, even strategic misrepresentation of preferences. Groupthink is a very, very easily occurring phenomenon, and this makes the responsibility of the facilitator a very important one. So the facilitator has to sort of pay attention to what's happening in the group and sort of manage the group behavior so that we avoid risks related to these things. So I've been sort of describing sort of negative things, but the fact really is that the decision analysis is used extensively. And we already heard that the industry is using it, but I think that the widest area where it is used is in environmental decision making. So there are big groups in environmental management communities who are daily using decision analysis, in particular value tree multi-attribute type analysis. So it is a very useful tool today in different areas, but it's also used in global problems. As an example, I show here the CMI work. CMI is a peace broker institution in Finland established by our former president who got the Peace Prize in 2008. And my students are working there, and they have actually brought in decision analytical tools which they are using. I'm here showing some stuff which relates to Egypt's sort of domestic crisis, but I can't show you pictures, but they're actually doing the same kind of analysis across the nations in Middle East who are having these pretty big problems there. So decision analysis is used in important problems, so we need to be optimistic about its future. So this gives me a reason to jump back to Howard Reifa in his career. So he also studied negotiation science. He was active in the negotiations in YASA, and he was teaching students in Harvard, and he actually noticed that you can actually easily use student experiments to find new ways of negotiating and using the negotiation models. So he says that collectively we could test what worked and discuss whether the heuristic insight would be applicable in the real world. So these kind of student experiments were part of the basis of his book, which is The Art and Science of Negotiation. So it includes analytical models, game theoretical models, but a lot of behavioral insights as well. And one interesting case that he analyzes in his book is the Camp David negotiations in the 70s. So this was a procedure where the facilitator or mediator was Jimmy Carter, president, and then Egypt and Israel were trying to find a deal after the war. And the technique that was used there was the single negotiation text concept, where you go back and forth and give new ideas what to do and go forward like this. So technically this would be something which is called the joint gains process, so that you're searching for solutions where each side in each step has a gain. So you create a text where everybody is improving their position, and then you are finding a solution. And the interesting behavioral stuff which is discussed in his book is that, of course, this kind of a process depends on the starting point and how do you do, and then it could also include misrepresentation of preferences. Now we could expand a little bit the perspective. So behavioral issues have been recognized in decision analysis settings, but they are equally important in modeling studies in general. So we could start to inform the modeling community that behavioral things are important, and before we have been thinking that the decision maker has biases, but now we also have to consider the possibility that we as modelers have biases. So there's an emerging research area called behavioral operational research, which actively looks at these things. To think of the future, we could also see that we know from Damasio's work and others that emotions are important in decision making. So if we need emotions to make decisions, and can we have something to help decision making by studying the brain with these new neuroeconomic measurement things. So does it help us to understand where things take place in the head to support rational decision making? So we know, for example, that when we evaluate rewards, that takes place in a different place, and when we evaluate risks, that's another place. So is there a likelihood that in the future we can use some of these kind of learnings to develop better ways to support decision analysis? So to summarize, Howard Rafer was clearly aware of the importance of behavioral issues, and today we should continue his path by taking this into account and developing processes and practices and people who are aware of the behavioral stuff. Thank you.
Thank you very much.